The agenda today we'll have to have a short introduction to PoE lighting. We'll talk about the advantages of PoE lighting, and after that we'll talk about DC lighting as well. Yeah, you might have come across these words, PoE light and DC lights, and these concepts are gaining more and more interest. And as I said, today we would like to give you a short introduction to both concepts. And we'll start with a short overview of our product portfolio. We have, as Microsens, a broad product portfolio when it comes to IT networking. But today we would like to focus on the lighting part of the Microsens smart product portfolio. And we'll skip the part on the right side, the smart building part, and also the automation, because we've talked about this last week in another webinar. And for those of you who couldn't join our webinar on smart building automation via IP, I would like to give you a really short summary about what we've discussed. And for those who've joined last week, we just want to check if you've paid any attention last week. So let's have a short look at this. So digital buildings or smart buildings, sustainable buildings. A lot of companies, manufacturers use these kind of buzzwords, but no one really knows what it is and what it stands for and what is really smart. Most of the times, a so-called smart building will look like this. So every automation part in the building has its own smart solution. And it fills the building with numerous of devices, cables, and making use of all kind of protocols. And every system can be called smart. So there might be a smart lighting, smart heating, and so on, or smart access points, and a lot of smart things in your building, but it still doesn't make your building really smart. And at Microsens, we believe that a building can only be smart when the foundation of the building is smart. And to handle the increased bandwidth needs in the building, we of course recommend you to use fiber and our fiber to the office approach. And for smart infrastructure, we believe it's not just the cabling you'll have to look at, but also the protocols you use in a building. We think that the goal should be that all devices in a building, all smart devices, speak one common language. This means using one standard and widely spread protocol. And we use IP because we think this is widely spread. And you can build a strong, secure, and flexible IT network as a foundation. And once this foundation is in place, you can build a real smart IP-based automation system in your building. And the best example maybe of this kind of approach is voice over IP, which you probably all know. In the past, you would have separate cabling for telephony and for data, but nowadays telephones and your phone is connected to the data communication cabling, and everything is directed via the data cabling via IP. And we think this is in future, it will not only be voice over IP and data over IP, but also a lot of other services using this protocol. And this brings us to our first topic of today, PoE lighting. You might call it as well lighting via IP. And at the beginning, we'll try to show you this video. I hope the sounds work. We had some issues in the morning, but we'll just try. This will give you a short introduction.
Sound. Try with the sound.
There's no sound on?
There's no sound? Okay, then we'll just skip this part, and I forwarded the video to Fleur as well, and she will share it with you. So this you just had a few seconds of footage of our head of development, but with no sound. Then we'll just try to explain it in another way. Nico, maybe you can you can use this this page, and you can have a short explanation on the PoE lighting solution.
Okay, so maybe I will take over right now. What you see here is the basic concept of about PoE lighting. In general, you have a networks part, which is represented on the left top side with this small micro switch. This micro switch is a standard network device, a managed network device, which is also able to provide PoE power. And we use this feature to feed lighting. So this is the main idea behind. So doing this, we have developed our smart light controller, this SLC. This is a device which is fed via PoE with power and data. And on the other side, it drives a naked LED. I'm say naked LED because the LED lighting systems you use for those kind of solution needs to be delivered without any internal or integrated driver. So this only the LED array is needed. So this device is driven by the smart light controller, and on this smart light controller is also provided the ability to connect a smart sensor, which is able to detect motion, humidity, brightness, and temperature. So the newest generation of our smart light sensor provides also a beacon, Bluetooth beacon functionality, which could be used for further applications like indoor navigation, for example. So the main idea behind PoE lighting is to don't spend a dedicated lighting infrastructure to the building, but use the existing Ethernet network inside the building to run also the lighting. So lighting becomes the same integrated, like the example Falco mentioned before with the telephony, which is today a standard voice over IP system. You connect directly to the network. So what happens here in this picture is you have a sensor which is detecting, for example, the brightness in the room. This information is transferred through the smart light controller to the switch, and inside the switch we run an intelligent automation platform which is treating the data from the sensor, and depending on the values of the sensor, he sends the command to the smart light controller, dim up or dim down the lighting in the room, or switch the light on when motion is detected, for example. So this is the basic idea. The smallest lighting solution is this with the single channel smart light controller, and we can run maximum, depending to the standard PoE standard, 30 watt as total power for the port. The actual PoE standard covers 60, and the newest one is also able to run up to 90 watt per port. So this means by using the right smart light device, smart light controller, you can power LED luminance up to 19 watt PoE port output power, and transfer this power through the smart light control to the device. So in this picture you see a small difference compared to the previous page. We have this small micro switch on the left side, and then this device is connected to the backbone network, which is represented with this bigger multi-port switch on the top. This switch on the top has only one task: to deliver ports with the right PoE size to the field. So normally if you run a 90 watt for an 24 port 90 watt switch, you can connect to this switch devices from 30 up to 90 watts. According to the exchange protocol LLDP, the device is smart enough to recognize what kind of controller is connected and switch down or switch up the power which is delivered to the smart light controller. So you see here we have 3 different smart light controller. The smallest one is the single channel smart light controller, which is in the diagram. On the top we have the 2-channel and the 6-channel smart light controller. All of those controllers provide outputs which are independent from each other. This means you can, over the automation, control each channel independently. The 2-channel smart light controller is able to deliver up to 60 watt in total, but the maximum per each port is 50 watts. This means you can run 50 watt in one port output power. Then the second port can run only 10 watts, but in total you have this limitation of 60. The same is also valid for the 6-channel smart light controller. You can run per port up to 50 watts, but in total only 90. So this means you can connect individually lighting or luminaires with different power range and control those independently. So there's no need to run all the ports in parallel with the same level. You can configure them individually over the commissioning of the device. This task is called in our world calibration, and with the calibration you define what is the maximum output you have to deliver to the connected LED device, and you can connect up to 6 independently to those devices. So we have the same, each of our smart light controller is able to connect a smart sensor. The 2-channel smart lighting sensor is able to get connected to smart sensors. You can connect the smart sensors as daisy chain. You have one input, and on the smart sensor you have 2 RG45 plugs or connectors where you can connect via daisy chain the second or third or up to 6 smart sensors. So this is the general architecture. So you see you need a small micro switch inside the room to do your networking and also to host the automation platform, and the bigger switch on top is only to deliver the ports in the right quantity you needed for your application. So the automation platform is independent from the quantity of PoE ports they will handle. So you see you can combine an existing fiber to the office architecture delivered with the micro switches from Microsens, and you have in the background or the backbone a multi-port PoE switch to deliver data and power to the smart light devices. So what is also important that on this micro switch where you run your automation platform, you have also integrated a web server, and over this web server you can provide local control web pages where you can control lighting and also other room automation tasks like blinds and heating or cooling, for example. We have the ability to control over this automation platform, also over the data we pick up from the sensors, other values inside the room. This could be next to brightness, also temperature control and humidity, and the automation platform inside the switch is running the completely application, the task. So I think this is the the main overview, you see it's quite simple. An existing network based on microswitches or PLMs could be used to get expanded by a bigger multi-port switch to run your lighting infrastructure. And the most important thing is that you have the completely networking infrastructure is based on Edge 45 cabling. You don't have to spend dedicated cabling. You use the standard CAT cabling for setting up your infrastructure inside the building. And so you can connect your lighting system next to your phone as a second system directly into your network. So another important advantage of those systems is that because everything is based on this PoE standard and on this networking hardware component, there's no need to do this job by an electrician, which is an obligation if you run systems by 230 volts. This is PoE, these are network components, and so a network system integrator is able to do this job without calling third-party electricians. So I think this is the main description of this PoE lighting system. It's an expansion of the existing network system inside the building, and by doing this you can provide to the customer the full control about lighting inside the building by taking the advantages provided by an encrypted and safe network infrastructure. This means the network administrator is able to control the completely system and also be master of the security topics, because all those devices connected to the network run encrypted protocols. We have no proprietary protocols in the system. What we use here are standard open IP protocols, and the devices talk to the application platform over MQTT. This is also important because this allows you to connect those smart light devices also or integrate them into a cloud platform, connect them to a broker and exchange data also with third-party systems via MQTT. I think this is a quick and general overview about the smart lighting solution. And Falco, you can.
Yeah, we can. Yeah, you already started talking about all the advantages of PoE lighting, and yes, we just summarized them here. So you've already discussed this. So advantage of PoE lighting is that you use significantly less power for lighting because you use LED technology. What you said already was that you use an IP-based solution, and by this all communication is of course encrypted and secure. And like I've already said in the beginning, there are a lot of smart solutions, but a lot of them aren't really that secure. And if you use an IP-based solution, you know you have an encrypted and secure solution in place. Low voltage solution, like Nico already pointed out, you would need no trained electrician during installation and also during maintenance. I think that's also an important part, because most of you know that calling someone an electrician, getting an appointment to do some work on electricity or on the lighting part can take you a few weeks. But if you can do it yourself as a system administrator, just changing a light bulb without any interference of an electrician, this of course is very, very good and much cheaper. Easy and standardized installation, so you use CAT cables only. Network and lighting use the same cabling infrastructure. As we pointed out, the lighting is part of the existing IP network, so you need no new cabling or central distribution rooms to implement these kind of solutions. And Nico already talked about a few functionalities which are implemented in our PoE lighting system. So dimming, auto dimming is more or less a standard lighting solution you all probably know. Then there's something like human-centric lighting included as well. So this is imitating the daylight outside. So in the morning you'll have this warm light, in the afternoon you will have a more brighter light, and in the evening it will you will have this warmer light again. And this is proven to increase the productivity and also the well-being of your employees. And then there's follow me light as well. We have this implemented in our solutions and in a few of our projects as well. As Nico mentioned, you are not limited to a specific lighting manufacturer. All lighting brands can be integrated as long as there isn't an LED driver integrated in the luminaire itself. And the last part is Microsens PoE Lighting is part of Microsens IP-based room automation concept. So we not only deliver these kind of PoE lighting or DC lighting solutions, but we have a solution which is based on IP for a complete room automation in your office or in your building. As Thomas already pointed out, if you have some questions about PoE lighting, please write them down in the chat, and we'll answer the questions after this presentation. And then we'll just move on to the next topic, which is DC lighting, direct current lighting. So we can see on the market in the US and also some other countries, we see a trend where the use of direct current is gaining popularity. It's, for example, used in more and more data centers, but also in buildings. And the main driver of these trends is the wish of building owners to be more autarkic. They want to make full use of renewable energy, and they want to be less dependent on the power grid. And for these kind of solutions, DC and DC lighting are an ideal solution, especially when it's used in combination with building own solar panels, storage batteries, and so on. So these already work with DC voltage, and rectifiers and the associated electrical losses don't have to be considered in DC infrastructures. As a rule, you might know already, is that every conversion from AC to DC and vice versa, this will result in a loss of approximately 20 to 25% on energy. So using DC lighting can help you save energy. And we see on the market also that will be an increased demand on power over the coming years, especially with the rise of electrical cars, electrical heat pumps, and a lot of other electrical equipment in the buildings itself. And we already know there will be more and more focus of governments on green and sustainable solutions. So it is hard to imagine really that DC buildings will play a significant part in tackling some of these issues. And DC lighting will be a part of the solution as well. The smart lighting controllers we showed you before, they run on DC voltage as well. Our complete networking devices for fiber to the office, FTTO, our micro switches, they run on 54 volts DC as well. So we can not only provide a sustainable and energy-saving lighting solution, but you can build in your building a complete, sustainable, flexible, and fully DC-powered data network with our solutions as well. And as we said, we've already had a look at the smart lighting controller, and maybe the DC lighting system can profit from our central smart lighting controller as well. So Nico, if you can explain a bit about this part.
Yes, so what you see here is our DC lighting system. We call it DC lighting system because it's like Falco mentioned before, based on a desync power in structure. So what you see here is you have 24 power channels which can run up to 50 watt each, and you can connect to each of this PoE. It's not PoE. To each port and luminaire, which could be controlled individually from the automation part. You see this AG45 connectors. We use them only to have a standardized cabling. You can use the standard CAT cabling from the network also to connect luminaires. So this helps to make the handling with the cabling easier. And on the other side, this device is connected via an uplink to the network to get data or transmit data from collected over the sensors directly to other instances inside the building, maybe to other micro switches connected in the room. The device is able to run also this automation platform we have talked before for the micro switches. So this means by connecting smart sensors in a daisy chain mode, like you can see here, you can connect up to 24 sensors and 24 luminaires, and the information you get from the sensors are directly sent to the automation platform inside this device. And based on the sensor information, you can run all the individual functions and tasks for the lighting part inside the building. In general, this device is a 24-channel DC-fed light controller with an integrated automation platform, which is free programmable. And you can run next to lighting also other automation tasks in the room. For example, you can control blinds from this device. For example, if you get the information from third party about wall buttons, you can control over this device also the blinds or the heating control, because the automation platform integrated in this device could get over network third party informations and treat them. All the data exchange between the Microsens devices happens over MQTT, so that it makes it easy to get connected also to third-party devices or to get connected into a cloud, to the broker, which is located in a cloud. So the same preconditions we have mentioned to the PoE, that the luminaires connected to this smart controller or DC lighting system needs to be naked LED arrays without integrated driver. This means as long as this condition is fulfilled, you can run any luminaire available on the market. So on the other side, you have a really small device which could be connected in a rack in a suspended ceiling, or you can decide to connect this also on a central point somewhere in the building. So the conditions you have to keep in mind for the RG45 cabling is the same like for the Ethernet, maximum 100 meters from the port to the luminaire. On the other side, you can enlarge this distance if you connect you can. The problem with the 100 meters is a clear Ethernet limitation. Here you can run this 100 meters directly from the device to the luminaire, and this is the only thing you have to keep in mind. What is also important to know, the sensors connected to this device are based on a bus structure. The last one has to be terminated with a termination resistor, and in total you can run 24 sensors, which could be assigned to each of them to a luminaire or to a segment or to a zone which is defined inside the application. So this two concepts we have seen here allows you to have an up-to-date modern lighting system inside the building. So both systems are DC feeded, and this could be really nice combined with the photovoltaic system, which get more popular actually, so that you can provide a system to a customer which is green, which allows you to use a system with less conversion losses, like you have it on AC DC systems or AC DC conversions. And yeah, you are flexible because the DC systems inside the building compared to the AC systems could be also feeded over the grid. So this means if you don't have enough DC power from your photovoltaic systems, all those systems are also backup or connected to the grid, so that additional energy in case of non enough DC power could be fed by the grid, but at the same time also too much produced energy on the DC side could be fed to batteries or could be fed back into the grid. So you could run a system which is up to date from the conditions. It keeps you all the possibilities of a green system, and meets also the requirements of the future, and helps to support the actual discussions we have about the climate and green solutions on the market. So I think this was a quick overview about those two concepts, and yeah, Falco, you can take over.
It really depends on the project, of course, which of the two solutions you would like to implement. Maybe on this page you can see also there's a LED light with dual tone lighting. This can be done with the 6-channel SLC as well. So you can really change the color of the LED lights, making it more warm or more cold, whatever you need in your system. The lighting can of course be handled by a simple wall switch. It can be managed centrally, and this page shows you a real basic setup of a GUI, so a graphical user interface, which can be run on a tablet, on a PC, or on a phone. And yeah, you can see, well, it's not too exciting maybe for most of you, so you can turn the lights on and off. You can dim the lights to 50%, but you can also set the dim level. So you can really choose, if you click on this button, dim, how far do you want it to be dimmed? So standard will be dimmed to 50%, but if you want it to be dimmed to 20% or 75%, you can just change it in this GUI as well. And yeah, if you set it to automated, then it will be controlled by the sensor. So if there's a lot of light on the sensor, it's bright enough in the room, then the light will automatically dim, and the other way around, of course. Like I said, it's maybe nothing too exciting, but it's yeah, we had this research lately in the Netherlands where it showed that it's about 70% of all commercial used buildings leave at least a few lights on during the night. So I thought it would be maybe 10 or 20% of the office buildings where lights will still be on at night, but it's more than 70% of the buildings where this is the case. So you can imagine how much energy can be saved by simply automating your lighting. The advantage of DC lighting, as you probably heard, most advantages are the same as the advantage you have with PoE lighting as well. And the only big difference is that maybe when you use DC, that you need less converters, and yeah, thus you need fewer components are needed in the building, and this of course more efficient and saves a lot of maintenance as well. And on the bottom you can have a look at what Nico already discussed. So you can use power which is coming from the solar panels or from the sun, and use the sunlight in the building, either directly or via a battery, where you store the power. And if there's any power left, if you have too much power, then you can feed this into the grid. And if you have not enough power, then you can take energy from the grid, making it really a green solution for your building. We now would like to have a quick look at some of our projects, which we've worked on during the last years. We're working on some other projects at the moment, with some rather big projects in India and in the Middle East as well. But we want to show you this solution as maybe to give you a bit more background as well. So you can of course light office buildings, which is maybe like a standard solution, but this is a solution we did for a hotel. And you can see that the smart lighting controllers and all the automation is placed in a little box, and this box is placed in the furniture. This furniture, this closet is locked, so the customer or the guest can't reach it, but the maintenance can. So if the guest leaves, then the maintenance can just go for this box and do all the automation and check all the automation. Maybe if something broken, it's all in one little box placed here inside of the room. And yeah, here you can see it's not just lighting which is automated, but also a lot of other services which are placed on a tablet. And yeah, Nico, maybe you can have a quick explanation on this project and then on the box solution, which is as well.
As I mentioned before, the lighting solution from Microsens is only a part of the room automation concept we provide. So what you have seen before were some pictures from our hotel we made in Poland. So all the rooms are completely automated by our smart concept. The lighting inside the rooms are based on LED lighting fed by smart light controller. You can see here in the picture on the bottom left side we have a box where you have the smart light controllers in, and these controllers are directly connected to the luminaires inside the room. Additionally, we have also smart I/O controller shown in the middle here, where you use the mouse file. The smart I/O controller is doing a similar thing like the smart light controller. It is fed by PoE, and you can connect conventional signals like analog inputs from 0 to 10 volt, or digital inputs, dry contacts. You can feed analog outputs 0 to 10 volt for valves, or digital outputs to switch something directly. And these devices are also fed by PoE from the switch. So the full automation inside the room, you can see here, is delivered by smart light controllers or smart I/O controller. And the fuses you see on the cabinet on the left side is only to deliver the 230 volt which were required in this hotel. But you have those cabinets installed inside the furniture. All the devices which are integrated in these boxes are PoE fed, or a Notion, where we use a Notion to pick up, for example, the buttons, wall buttons, and so on. And the completely automation part inside this room, which cover heating, cooling, blinds, lights, floor heaters, and so on, is integrated inside our industrial switches and the PLM, which is shown in the cabinet on the left side. So this what you see in one sentence, what you see here, you have an existing backbone network inside the building, which is expanded by these switches are located inside the rooms, and the switches inside the room run the completely automation you need for this hotel application. What important to the configuration of this is the completely hotel runs one big fat network, and any application is running in his virtual network. For example, the room automation has his own virtual network for access points for VLAN run in a separate virtual network. Connection to the hotel management system is also another virtual network. So why I mentioned this, it shows that the network administrator is able, by doing a smart configuration of his network system, to cover not only the needs for networking, but also the needs for other systems in the inside the building. And everything you have here is based on network, is IP based. So this allows you to control also the automation part from the IT side by providing a safe environment administrated by the system administrator. This was an example from room automation or building automation. Another example would be shown here. This is a smart light pole. You have a pole where you have a PLM industrial switch inside. In this switch, you have connected smart light controllers, and those smart light controllers could run LED luminaires you see on the top. This pole is connected to a network, so it could deliver data from the pole's location to a central point. It could be controlled centrally, or it could run independent automation on site. You can control over this pole also via surveillance systems, via PCAM activities in the area. And this is one application from one of our customers in Russia. They want to promote those poles to the market, and this is also another example how smart solutions could look like, or what they could do. So you have an IP camera to do observations, or to do provide surveillance features. You have LED lighting, which could be case dependent switched on or off. If, for example, the IP camera is locating that somebody is near, you can switch the lights on, or dim it up or dim it down if nobody is close to the light. So you see, you can realize application in a really smart way, which helps you to provide more comfort to the people, and on the other side to save also energy. With the surveillance system, you can provide the feeling of security in public areas, and also this topic with the Wi-Fi access points for smart city concepts, for example, could be realized in a smart solution like this. Here you cover automation, lighting, access points, and surveillance systems. So this is, I think, from my point of view, the meaning of smart. You combine different systems, and everything is communicating over networks or over IP by running open protocols. In those cases, also MQTT. And I think we are in front of the beginning of a smart new generation of application and solutions. For sure, we have building automation, conventional building automation inside buildings, but I think next generation will be shown applications and solutions like this.
Okay. So I think what we just wanted to point out with these last few slides is that we're open to discussions with manufacturers, with building owners, with system integrators, which might have some better ideas than we have. are similar ideas as we have, and we would like to come into discussion with you and see what how we can help out and yeah, what we can do together. So we come now to the end of this presentation, and